Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Chris Jackson. And we got a question from one of our listeners, which is one of our favorite things to talk about.
Yeah, and I only told you that much about it, so you didn't have much to lead into.
No,
Sorry
I'm
about
trying
that, Chris.
Just work with me here.
Yeah, all right. It was a question that came through on LinkedIn, and this young guy, or I don't know how old he is in the asset management maintenance side of reliability engineering, and said, I'm learning different tools and different stuff and problem solving and failure analysis and all these things, but I don't really have a good strength in statistics. And is it worth pursuing a degree or pursuing getting educated and competent with statistics and reliability statistics? Is that good for my career? And so, of course, I could have answered that with a one-word response, yes. But I thought I filled it in a little bit more and why I thought it would be a good idea. But I guess the underlying question is the understanding of statistics in general necessary, would be the way I'd phrase it, but a good thing to do if you're working in the field of reliability engineering.
We can make this a very short podcast.
Yeah, I know. We should explain it a little bit for those that are considering this and maybe not have not even thought of the question.
Yeah, I mean, cut this bit out in the editing later on if it's not appropriate. But I've just recently finished my Weibull analysis course, and it's all about understanding what statistics mean versus finding statistics.
Mm-hmm.
And I think you got your postgraduate degrees, or graduate degrees, I should say, postgrad. What do you call them?
Anyway, master's degree. It's a master's.
Yeah.
It's a step short of the PhD.
And I got something similar as well. And so I'd argue I'm very familiar with the true high level statistics. I go so far as that I'm so awesome at statistics that my PhD dissertation has been applied to absolutely no real world problem because it's so complex and so specific to a particular problem that wows the dissertation committee, but then all the maths and tricky stuff and numerical solutions that need to invoke. But yeah, it's so good that no one really cares. That's how good it is. I'm being flippant about it.
Yeah, it's one of the many reasons I didn't pursue a PhD, besides not having time or the funds to do it. But yeah, you know a whole lot about nothing, is kind of what you're saying.
Right. And what was never taught to me, and what I really try to flavor my courses with is, well, what does this mean? And it was so refreshing for me when the penny dropped that this pick Weibull analysis, that you can actually answer pretty much all the questions you need to by understanding the statistical fingerprints of things you're looking for and just visually seeing them in a chart.
Mm-hmm.
And to many engineers, that sounds like, it would have sounded to me at the time as a cheating way of doing statistics, or that's what people who don't know how to do statistics, that's how they do statistics. They do charts and don't do the equations. They don't integrate complex equations using partial derivatives and everything else the sorts of questions you get asked in university exams. But for me, it's all I do now, and I do have, like I said, I've got that amazing dissertation that no one cares about. That's how good it is. So
Mm-hmm.
I've got the theory to fall back on, and I know you do too. So I suppose the question that's being asked is, should you learn how to do statistics? And I'd say the answer is absolutely yes. But there's good statistics and bad statistics. I believe, Fred, you maintain a website that sort of does touches on bad statistics. I could be wrong. I might be thinking of another Fred Schenkelberg. It's a common
Yeah,
name.
no, no, no. But yeah, I think, well, part of the trouble here is, we have a long history of knowing the value and the usefulness of even basic statistics, of just even a hypothesis test or a Weibull plot, and how powerful just the results you get and the graphics you can pull out of these things, or even just taking a data set and plotting it two, three different ways and it's going, okay, what's going on here? And using the range of tools that are available to explore data sets, to understand patterns and variation and so on. And one of the things I latched onto in my background, and it was before I had even pursued any courses in statistics, is that variation happens. It just is everywhere. And I'm on a manufacturing floor trying to produce a consistent, working in spec type product. And our charter as the manufacturing engineers is reduce the variation. So we had to be conversant in the language of variation. And that happens to be statistics. So we were learning all these cool tools and plotting techniques and methods and ways to approach our problems. And it just became so utterly useful that I was halfway to a degree before I even, applied for the program, right? Because they were offering these courses to our company. Uh, and it was paid for by the company, and I could go into a small classroom in my building and sit and attend these courses and lectures. And I wasn't getting credit for them, yet the company agreed to pay for the credit part of it after I said, well, I'm halfway through these courses. I need to take some more because those look really practical. And I think I was forced to take one theoretical class, almost failed it. Um, but it's the reason to be good in statistics is that variation happens, and we need to be able to grapple with that and see patterns and understand where it's coming from or what are different changes in patterns, and all of those things are what statistical toolbox of stuff is all about.
Right, and not only that, it's just I think people are obviously intimidated by statistics, but once it's your friend, the best thing about knowing being confident in statistics is knowing what statistics you don't need to worry about.
Yeah.
When you're not confident, every statistic or every technique that has ever been taught to you ever feels like it's mandated and required, and it is overwhelming, and it doesn't have to be that way. I think that's one of the more liberating things is when you know statistics, you're not afraid of them, and it also means that not that you're in the business of deliberately trying to call people out, but you can call people out, um, and it helps you become, in many cases, if you're the only guy or girl who knows statistics in your organization, for whatever that means,
Mm-hmm.
then you will eventually save the bacon of your boss one day, where you say, hang on. This number here, which you say is great, and it's measuring the wrong thing, or you use the wrong approach to get there, and all of a sudden you will eventually save the bacon of the program lead who is going to launch a disastrously unreliable product, or perhaps if you go the other way, launch a product without having a truly long warranty period because it's reliable enough to have one. And so you will
Yeah.
eventually save the bacon of someone who doesn't understand statistics. And most engineers don't understand like the MTTF, as you know, Fred.
Right.
And if you can become that person, you also need to be able to, well, sorry, I wouldn't say need to, but it's also useful to be able to hold a conversation with someone who thinks they know about statistics. And because of that, they are the ones who are seen as the patron saint of statistics in the organization they're part of. And yeah, you don't have to be subservient to those people.
Yeah. Yeah, I get that all the time. Is where you have a master black belt that is cursory informed on. I ran into this personally. Just had a textbook on statistics. I don't think ever read it, yet was deemed the go-to statistician. And I found very quickly that no, this person doesn't really know what in the world they're talking about. And that goes back to this question: is it's one thing to pick up a handful of tools and apply them, but that can get you in trouble with very, very quickly. If you're working on your house and you're trying to, swap out a circuit or a plug in your house, and you're using the wrong tools and the wrong techniques without understanding that if you cross these two wires, you're going to cause a fire, kind of thing. The same can be said for statistics. People will pick up whatever technique and apply it and hope for the best, but with real no understanding, is this useful or practical, or does it give me a meaningful results? And I think the understanding of statistics, it touches on what you talked about, Chris, is that you don't have to be afraid of it anymore, and you don't have to use it blindly. You use it with intent to solve problems, to garner information, to find variation, things you can do about it, things like that. But it does take a bit of work. And part of what you were talking about just now, Chris, was that it is a downside, because once you're deemed the stats person in the group, you will get questions on the regular about, well, how many samples do I need for this? It is the number one question I had received once people figured out that I knew what I was doing with statistics. And usually it was a frustrating experience, because for what you want to do, you need 8,227 samples. He says, well, I only have 3. Well, then you can't get there from here. Kind of thing. What other options do we have available? And then you get better at dealing with constraints and what are the viable options to still get a meaningful result. But yeah, be prepared. And maybe you're already getting this. Maybe you're already getting questions of, well, how many samples do I need? Well, understanding statistics is a great tool to help answer that question.
Right. And I still think statistics is very liberating. It doesn't seem that way. You sort of maybe sold it poorly when you said you become the statistics guy or girl in your organization. I don't know if that's going to attract too many flies to that, honey. But yeah, I think one of the challenges with reliability engineering and asset management is being confident to not do something. Same with quality. I recall it being bandied around that about 80% of quality interventions, as in things done in response to perceived defective production lines and things like that, are unnecessary or counterproductive. That is, we're scared of doing nothing when we see something which could be bad, and all of a sudden we do something. And of course, if you don't need to do something, it almost always leads to a bad outcome.
Yeah. If nothing else, just wasted time.
Right. And so it's just it's a challenge. But when you get comfortable with statistics, you can say, we don't need to worry about that. We are good. Or we say, look, one of the things I say a lot is that if everything's important, then nothing's important.
Mm-hmm.
And one of the challenges of reliability engineering is just working out what doesn't have to be subjected to 65 peer-reviewed studies of, failure mechanisms down to microscopic subatomic levels. Having confidence to understand, no, that component's been used in the previous model. It's fine. We don't need to re-V and V it. Let's focus on the new components that are going to ruin our day and go from there.
Yeah.
Yeah. So I think there's a lot to it. What was the exact wording in the question? It seems somewhat naive to ask that. Is it a good thing?
Well, I don't think it's naive. I've run into plenty of reliability engineers that have no statistical background or training at all. And when they need to do a Weibull plot, they just open up a package of software and plot it and just push the button. I mean, I was as an expert witness in a case, and part of the discovery was a whole series of analysis of field returns. And every week they would tally up the returns and do a plot from that week's production. It was it was censored data and they took care of that all right, but they used the wizard in the ReliaSoft Weibull plus plus package. And one week it was gamma, the next week it was a three parameter Weibull with a negative uh, failure free period, so that they pretty much created a formula for products that hadn't existed yet. And I thought, okay, that's a red flag. It's probably not a good, but they in their testimony, in their yeah, not testimonial, their when they got interviewed, it was they just used whatever the package said was the best fit. And that is a
Right.
sure sign you really don't know what the hell you're doing.
Right.
And and it was, yeah, you can do air quote statistics and tally up numbers and create averages or create a plot or compare, do things. Yet, if you don't understand some of the underlying pieces to this, I don't think you need to go to the what level you did, Chris, and get the, you know, exquisite study of something that's not practical in our
Oh, you
day-to-day
don't? Yes,
life.
I'm not trying to. I'll advocate that was a spectacular waste of time. I mean, it really did. It did hone my statistical skills. I
Oh
have to be
yeah.
honest.
Yeah. No, you're
But it didn't fix much in the world.
right. With the understanding, the stretching of being familiar with so many different things, because you studied way more than what was just in your thesis. It was all of the underpinnings of all those other tools and techniques that got you there. And even spending time on Ascendo reliability, reading the articles focused on statistics, and they tend to give you a bit more insights on why we make these assumptions and stuff like that. That's better than just using a software package blindly. And then next would be take some courses and seminars like your Weibull course, Chris, and do the listen to the podcast on statistics and the or the webinars we do on it. Get a little bit deeper into it. Now, if you find that you really want to buckle down and focus on it, then get a university program or take a series of courses that get you closer to a good understanding, good, solid working understanding of the tools that you need to use or want to use.
I caution against that. But if I'm going to be, maybe you had a
All
different
right.
experience to me.
Yeah.
But I think that a basic example is that in university courses, you get assessed on your ability to integrate the area under curves, for example, which is, for those who know, is part of the probability density curve thing,
Mm-hmm.
and where you need to create, the bell curves and variations thereof need to have an area beneath that curve equal to one, and that sort of sets the platform for all subsequent data analysis. And so, one of the things we do in universities is have lots of questions where you integrate, I find the area under curves to demonstrate you can find the area under a curve for all sorts of weird and wonderful shapes and polynomials and everything else. Whereas in the real world, you already have the bell curve defined, you already have the log normal distribution defined, you already have the Weibull distribution defined. And unless you're going to invent a brand new distribution, like I was about to say, like what Wallotti Weibull did,
Yeah.
he didn't actually invent it though. Frichet invented it. It's one of those very
Popularized
frequent
it.
scenarios where the person who invented something doesn't get the naming rights.
Right.
But
Yeah.
unless you're going to do that and create your own distribution, you don't need to. You don't need to integrate under the curve.
Well, I had a very different experience, and it was actually an Australian visiting professor that was my favorite instructor. And it was very, very, very practical. It was in which I was looking for all the time because I was going right back to the shop, to the factory, and using it that day. My homework was beyond whatever they did in the class. I got to play with it every day with real data. Yeah, I mean, there
Well,
was mention, oh yeah, you got to do the integral and do this and that, but we were using Mathematica and other packages that, you know, he knew you could just do this. Now we did have to do some derivations and do other stuff to understand it, but the vast majority of courses I signed up for were very practical. And there was, like I said, the one that was theoretical. And so I sought out the practical stuff because I saw the value of it. Every time I ran into something, my brain's just spinning, going, "Oh, this would help me with this problem." And then we ran back to the shop and did it to the point where the guys on the floor, they're like, "All right, what do we got to do today? You're back with another experiment."
Yeah, so that's, I
I
mean,
know.
it's a valid point.
And I think you can do that though. You can do it, right?
Right. And I think, so long story short, we had different experiences, which
Yep.
is not uncommon for universities to have different teaching experiences.
Yep.
But that said, I'll highlight it as a hazard to be aware of, is that there are
Yes.
some universities out there who get what's the word I'm looking for? I don't know, get their rocks off. I don't know. Just it has to be hard. I remember speaking to professors saying, like, and I asked the question, well, this is a crazy curve you're asking us to identify to integrate under in set exam. Where does this come from? Why are we doing this? And the answer was, well, this graduate students need to be able to do this level of math, and the number of graduate students I've met who have in the field of reliability who cannot solve a real world problem is astounding. So yeah, so I think I was probably wrong to say, hey, be careful with university stuff because they're always impractical. You clearly disproved that assertion straight away, but mine was, if I'm going to be honest.
Yeah. No, and we should know better, Chris. We both have the sample size of one. Um, so it's it's kind of ironic, but we've also run into people that Ben Franklin ran into this year, centuries ago. He says, I know this guy that can speak 7 languages, but he rides a cow to work. It's book smart is one thing, yet there's a happy balance there. And you can learn enough about statistics by just being curious. What are the assumptions here? Does this work in this application? Can I check my work? Why is this a good fit? What is this? What does this really mean? What if I play with this? You can self-educate. There's no doubt about it, and make it practical. Yet, if you need the structure of a program or a series of courses or stuff like that, seek out the ones that fit with what you need. There's plenty of options. There's a page on Ascendo that lists, I think, about 20 different university programs. With each one has slightly different focuses and areas of expertise and so on. Talk to former students. Find out, is this a good fit for you? Yet between Ascendo and the existing literature out there in the world and the university programs, it's easier than ever to match up a program and pattern or a system for educating yourself to get up to speed. And I'm still learning. Every data set I get is a new experience, and sometimes frustration of how bad the data is. But I don't think we've solved that problem yet of getting good, clean data sets unless we make them up ourselves. Um, but anyway, the underlying thing is, I think Chris and I think most of the folks that deal with Sendo reliability would say, yes, understanding statistics is a career enhancer. It is good for you and your organization. So wholeheartedly pursue it.
Absolutely.
I was going to say, if there's anybody's listening to this and it's like, what in the world are you talking about? It's the most worthless study ever. Take underwater basket weaving instead. Um, you probably won't give us a shout because you skipped ahead to the next episode already. But what's your experience? If any of our listeners have the experience of working in reliability engineering and then getting a good handle on statistics, what difference did you see? Would be the question I have for you. What are the elements that maybe Chris and I missed here? What works for you? What made the difference for you? And you can do that over at accendoreliability.com/go/SOR. And there's a couple of ways to get in touch with us. Chris and I and the other hosts of the show are available through LinkedIn and our About pages. So if you got a question or something that you're interested in, or a great success story, or other types of questions and on other topics related to reliability, we'd love to hear it. And it's always an enjoyable discussion when we have a question that we can expand on. Um, And ask Chris what courses he took so you don't have to do those if you get
I'll do
to
one of
that
my
university.
courses.
Yeah, or do one at Chris's. They're very practical and very entertaining too, on top of it.
I know you're aware, Fred, of the naked mole rat example I use for
Hmm.
the exponential distribution.
Yep.
I use unicorns eating ice cream for the normal distribution lesson.
Okay.
Um, I can't recall if you're aware of that analogy, if I've included that in the webinar, but
Yeah, I saw that one. Yeah.
you saw that one.
Yeah.
My apologies. And I also
Yeah.
use the
Yeah.
magic carriage. I don't know. I can't keep up with whatever.
You just have too much fun putting these courses together. All right, Chris. Well, I knew I wanted to ask you to expand on this question because I suspected I knew the answer of that and I wanted to see where it went. And once again, another fun-filled adventure through statistics. So always good, Chris. well, we'll talk to you again soon.
All right, Fred, always a pleasure.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.